Hello friends, this video on organisms and population part 20 is brought to you by examfear.com. No more fear from exam. So now the question is how these population growth takes place, how the growth actually happens. Now when we start looking at the exact pattern of growth using graph, we get to see that there exists different types of growth models. So growth can also happen in a number of ways. It is not necessary that growth has to happen in a linear way. So there are different ways growth can happen. So let us look at the growth models. So the first model that we will talk about is the exponential growth model. What does it mean? It means that when the resources are adequate. Now, when do organisms grow? When there are more birds, when there is more immigration. So there will be more birds when there will be more immigration when the weather conditions are favorable. There are unlimited resources available for the survival and growth of living organisms. Similarly, more births will happen when all the conditions are suitable, you have enough resources. So basically, whenever the resources are adequate, when the resources are present in sufficient amount, in that case, the growth will keep on taking place. So the growth will happen very fast. Growth will happen exponentially. So that is the exponential growth model. So in this case, the population will increase exponentially. Population keeps growing very fast, because you have enough resources. It is something like this: if you have too many things to eat at your home and you keep eating all of them, if you continuously keep on eating, what will happen? Your weight will increase. So the similar thing happens here. Now if there are too much of resources available everywhere, so all the organisms will utilize the resources, and that's how the population will keep on increasing. So the population would grow exponentially. So graphically, this is how the exponential growth is mentioned. So as you see, with time, the population density, you can see, is increasing very fast. So this is an example of exponential growth. So now how do we express exponential growth mathematically? So that is what we will see. So let us say that since we know that the population in this case increases very fast, so that means we are bothered about the population density, which is denoted by n. Right? So now, as per our understanding, in exponential growth, the value of n will increase very fast. So let us say that at an initial time, say t is equal to 0. Let us say that the value of population density was n naught. And let us say that after time t, that is when time is equal to t, that time the population density was nt. So let's say this is how we denote the population density at different times. Now as per us, this increase from n naught to nt would have been huge because the population is growing exponentially. So what would be dn by dt? That is what we are interested in. That is how fast the population is growing. So whenever we define exponential growth, we say that this dn by dt is equal to b minus d into n. What is b? B denotes the birth rates and d denotes the death rates. So since here the population is increasing very fast, that means number of births are more than number of deaths. So b is greater than d. So b minus d, that is the net increase in the number of individuals, multiplied by n. That is, what is this n? This n is nothing but the population density. So why are we considering this n? Because we are talking about per capita birth rate. You remember, whenever we define B or D, whenever we are talking about birth rate or death rate, we are talking about per capita birth rate or per capita death rate. That is the number of deaths that happened per organism per year. So per year has been taken care by this dt, per organism has been taken care by this n. So this is the equation which defines the exponential growth of a population, and this curve represents the same relation, that is dn by dt. So if you find out the slope of this curve, so this would be dn by dt is equal to b minus d into n. Now this b minus d is often denoted by a small r, and this small r is known as the intrinsic. So this is important again. So this r is known as intrinsic rate of population increase. So this value, that is b minus d, actually decides how fast the population growth or how fast the population density would increase with time, because dn by dt will be more. That would mean that the population is growing very, very fast. So this is how exponential growth is mentioned or is denoted exponentially. So here dn by dt is the increase or decrease in population in unit time period, right? So let us now see how do we get this exponential relationship. So for that we will just try to derive the exponential growth equation from this very equation. So from this equation we can say dn by dt is equal to Rn, right? So from here we can say dn by n is equal to R dt. So now let us integrate on both sides from 0 to t. So that's how we are integrating. So basically here what do we get? This would be natural log of n. So this from 0 to t, and this is equal to RT. So I hope you know the basics of differentiation and integration. So that would help you to understand this. So this would be ln nt minus ln n naught is equal to RT. So even if you are not aware of the basic differentiation and integration, please learn them, refer the mathematics videos of class 12 because they are important. So now from here you can say log, natural log of nt by n naught is equal to RT. So what can we write? We can say, using the principles of mathematics, nt by n naught would be equal to e to the power RT. Or we can say nt is equal to n naught e to the power RT. So now when you look at this equation, you can see that it is an exponential equation. That is, the population density at any time t is equal to the population density at the initial time t is equal to 0 into e to the power RT. That means as the value of time increases from 1 to 2 to 3 to 4, what happens to the net value? So the net value keeps increasing exponentially because e to the power 1, e to the power 2, e to the power 3 and so on. So the value actually increases too much. So the population increases very, very fast. So this is how we derive the exponential equation, and that is why it is termed as exponential growth. But this type of population growth can take place only when the resources are unlimited, because without resources the population would not increase. So now, looking at the exponential growth equation, what can we interpret? So what was the exponential growth equation? That is dn by dt is equal to b minus d into n. So that is the exponential growth equation. So let us see what are the various cases that can be interpreted out of this equation. So let us consider case number 1. When the number of births is greater than the number of deaths, when more births have happened, in that case that would mean b minus d would be a positive number because b is greater than d. So what would that mean? Therefore, now since this is a positive number, so what will happen to dn by dt? So dn by dt would also be a positive number. And what does that mean? That is, dn by dt is nothing but the increase or decrease in population. It tells the change in population with time. Now, if the change in population with time is positive, that means the growth is happening unboundedly. So this type of growth would be termed as unbounded growth. So whenever number of births is more than number of deaths, it results in unbounded growth. Now, in the same equation, if we consider that b is less than d, that is, number of deaths are more than the number of births. So, in that case, b minus d would be less than 0. Therefore, dn by dt would also be less than 0. Correct? So that means what? The population is not increasing with time, rather the population is decreasing with time, and this can lead to a situation of extinction. So you would have seen a lot of animals become extinct over a period of time. For example, these days the number of tigers which are left behind are very few. Why? Their population is decreasing with time because the number of deaths that is happening is more when compared to the number of births. Similarly, let us consider the third scenario where we say that b is equal to d. So if b is equal to d, then what will happen? This the entire right hand side would be 0. So in this case, dn by dt will be equal to 0. That means the change of population density with time is 0, which means there is no change in population with time. That means the population remains constant, or we can say this is a scenario of stable population. That is, the population is neither decreasing in size or it is increasing in size. So the number of, if there are 10 births taking place in a year, then there are 10 deaths taking place in a year. So the overall population density will remain the same. So these are the three scenarios that can be interpreted from the exponential growth equation. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.